Welcome to In Depth with Academia. I'm Richard Price, your host, founder and CEO of academia.edu, and I'm here to explore new and sometimes, let's be honest, rather wild frontiers of academic research with you. Thanks for joining me. Okay, so today we're unpacking a thought-provoking and ambitious paper by Mark Traver called Non-LocalQualic Coherence in Quantum Biology and Networks. Converging Empirical Evidence for the Sentient-Field Hypothesis, or the SFH for short. As always, just a reminder, I'm here to present, not to endorse. My focus is on making sure you, the listener, come away with some clear insights and good questions to chew on. This paper is kind of a ride, so let's get started. So what core problem does Mark Traver tackle? Well, the big question is, why does our universe allow for things like stars, chemistry, minds, and, most mysteriously, subjective experience, consciousness? Standard physics, like the Standard Model and general relativity, are great at describing stuff like matter, energy, gravity, electromagnetism, but, Traver points out, they don't really answer why the fundamental constants of nature are tuned just right for life and consciousness to arise. Instead, consciousness gets treated like a byproduct or a side effect that pops up once brains get complex enough. But is that really enough? Here's where the Sentient-Field hypothesis steps in. Traver flips the script. He claims, wait for it, that sentience, meaning the capacity for experience, is not a late-stage bonus of neural complexity, but rather it's actually fundamental. It's woven into the fabric of the cosmos. Physical fields under this idea are qualic projections. Think of them as the experiential underpinnings of reality, optimized for two things: coherence, which is about long-range quantum correlations, and fertility, which is this kind of ability for the universe to grow complexity out of simple rules. That's bold, right? And again, I'm just presenting. To test the SFH, Traver uses both large-scale simulation and experimental results. This is where it gets technical, but I'll try not to lose anyone. First, he runs a computational simulation, a Monte Carlo experiment with 60,000 possible universes. Each universe gets its own set of values for 14 fundamental constants, all sampled around the real values known in physics. This includes things like the speed of light, gravitational constant, electron mass, all those. He then assesses how viable each universe is by checking which conditions allow for light, atoms, stars, and chemistry in a strict progression. He uses two key metrics: coherence, which measures something like persistence of quantum effects at the atomic and stellar scale, and fertility, which in this context is about how likely it is for complex low entropy structures to form the kicker. Our universe, yes, the actual one we live in, scores a sentient potential, that's H Nayas C plus F, of about 98.55. He calculates that out of those 60,000 simulated universes, only about 1 in 100,000 even comes close to matching or beating our universe for this specific combination. Statistically, that's huge. Like 5 sigma in physics terms, which is the kind of significance you hear about in particle discoveries at CERN. Makes you wonder, right? Okay, but simulations are just models. What about real evidence? Digression time. Has anyone ever really thought about how hard it is to actually measure subjective experience, like, is my blue the same as your blue? I guess in physics at least you get numbers, but really, consciousness is another level. But let's get back on track. So in the empirical world, Traver points to 5 recent studies from photonic networks to, get this, quantum coherence in microtubules inside the brain. One study found microtubule quantum effects actually delay anesthetic loss of consciousness. Another observed what's called biphoton entanglement in myelin sheaths, suggesting super-fast neural synchronization. One more fun fact, there was a 31.6% boost in learning variance when twin brains were coupled via entangled qubits. That's a real mouthful. And another study got 81% fidelity in quantum teleportation over 12 kilometers, which beats classical limits by a solid 21%. These kinds of results, Traver claims, show quantum coherence in biological networks outstripping what the Standard Model or general relativity would predict. He says this supports SFH, that consciousness might rely on, or even be a fundamental field that prioritizes coherence first. and complexity grows after. But please remember, these are findings and models, not established truths. Science moves forward by proposing, by questioning, and by challenging the boundaries. So, let's sum up. What does this mean for you? Traver's paper invites a radical rethink of consciousness, not just as a brain event, but maybe as a foundational quality of the universe itself, whether you buy it or not. It definitely throws down a fascinating challenge for both physicists and philosophers. Plus, it nudges us to keep an open mind about what we think is possible in the junction between brains, biology, and the underlying quantum world. If anything, this underscores that academic research is less about concrete answers and more about creative exploration. These results, simulations, empirical studies, are tools to get us thinking. Remember, you don't have to agree with Trevor, and I'm not saying you should, but if his ideas inspire you to question the relationship between mind and matter, then I say the paper's already done something valuable. That's it for today's episode of In Depth with Academia. If anything here sparked a question, or a healthy dose of skepticism, I hope you'll follow up, read a bit more, and maybe check out Mark Traver's work yourself. Stay curious, question everything, and join me next time for more journeys to the frontiers of academic thought. Thanks for listening.